Hello. We're going to start with our first example. We have the heights of young German men between 18 and 19. Follow a distribution that's approximately normal with a mean of 181 and a standard deviation of approximately 8. So the first thing I write is I want to define my random variable x, which is the height of 18 to 19 German man. And then I know that x, it tells me in the problem, follows a normal distribution. Tells me that in the problem, approximately normal, with a mean of 181. So we always write the mean first, and then we write the variance second. Well, the standard deviation is 8, which means the variance is 8 squared. I'm just going to write 8 squared because really what I care about is actually the standard deviation, not the variance, even though in this notation we write the variance. I care that the standard deviation is 8. So part A, I'm going to draw a labeled curve to represent the heights of these young men. So if I sketch a little normal curve, something like this, I'm going to, in the center of the curve, put the mean, 181. And then I like to put 3 tick marks on each side. Like so. And I'm going to add 8 and subtract 8 to each tick mark. So I have 189. I have, I have 189 plus 8 is 197. Plus 8 is 205. And then I'm also going to subtract 8 from each one. So 173, 165, and 157. Perfect. Okay, and that's drawing and label these curves. I could label this down here as the heights, Heights, of the men. I'm going to be lazy. Heights of the men in centimeters. All right, and then so I'm going to write down part B, I, double I, and triple I. Those are all my probabilities that I'm going to calculate. Find the probability that a randomly selected German man, so the probability that a randomly selected German man, part I, has a height that is greater than 189. 2, the probability that the height is less than 184. And number 3, the probability that the height is between 173 and 189. All right. So the first thing that's important here is that I think the only tricky part about this lesson is that in the last lesson with binomial distributions were discrete. So if it was greater than 189, then that meant greater than or equal to 190. But that was only for discrete values because in the last unit, you couldn't have anything between 180 and binomial, anything between 189 and 190. But this is a continuous variable. So we learned that greater than 189 is just the same thing actually as greater than or equal to 189. It does not matter. It gives the exact same answer. The reason why is because if we look at greater than 189, what I'm doing is I'm finding this area here. I'm finding the area that's greater than 189, and that is the probability. Well, that area, if I include 189 or not, this is a line at 189, and a line has no area. It's one-dimensional. It has no area. So greater than 189 and greater than or equal to 189 are the same. We're going to go to the calculator, and we're going to use normal CDF. We're going to go Menu, Statistics, Distributions, Normal CDF. You will never use anything other than normal CDF. You won't use PDF ever, only CDF. I'm going to type in the lower bound. Since I wanted greater than 189, my lower bound is 189. My upper bound, I'm just going to type in a really high number that's impossible. Like, you can't have a height that large, but I'll just make that my upper bound. If you make this too large, the calculator gets confused. So if you get an error, it might be because you went too big with that number. So don't go too large. Even 100,000 is plenty high in centimeters. The mean, we knew, mu is mean, was 181, and sigma is the standard deviation, and in this problem, the standard deviation was 8. And so we can press enter, and we have the answer is 0.159 to 3 sig figs. So I'm going to have 0.159. Next, less than 184. So I'm going to follow the same process. Less than 184. So I'm going to go menu. You can actually go statistics or probability. They both have distributions there. They have the same distributions. You have a couple ways to find normal CDF. Since I wanted less than 184, my lower bound is a really small number. So I know it's impossible to have a height of negative 1,000, but I'm just going to go really, really low for the lower bound. Honestly, if you went to 0, you would get the same answer. But just to be safe, you can always, with normal distributions, make your lower bound just really, really small, like negative 1,000,000 or negative 100,000. And then we wanted up to 184. We know the mean is still 181, and I know the standard deviation is 8. Enter, 0.646. Let's look, does that make sense in context of, if we look at the diagram above, less than 184. 184 might be somewhere around here. Less than 184 is more than half the curve, right? Because the halfway point's at the mean. That's the halfway point at the mean. Oh. And so, definitely 184 is more than half the curve, so the probability is more than 50%. So that does make sense to us. That's the halfway point, and 184 was more than halfway. It's maybe around there. So let's write 0.646. I already did. Last one is between 173 and 189. Between 173 and 189. It's a big part of the curve between those, so I think the probability will be somewhat high, but let's go and let's see. So menu, statistics, distributions, normal CDF is between 173, so I go from 173 up to the upper bound, which is 184. That's what the question, no, sorry, it was 189. 189. The mean is 181, and the standard deviation is 8. Bam, bam, and we have the answer 0.683. 0.683. Oh, let me use blue. And that's the end of that problem. The next one's going to be 0.683, a bit more challenging, but we'll keep practicing these skills.